Uh, Everyone feel welcome. I'm going to show you how to run ANOVA test in Excel, and if the results are significant, I will also show you how to follow it up with a post-hoc test. So we have three football teams here. For each team, the number of fielding errors in a season were measured for each player. So our task here is to do a hypothesis test to examine whether the mean number of fielding errors were the same across uh, the three teams. Now, the null hypothesis is that the mean for the three teams are the same. Mean for team 1 equals mean for team 2 equals mean for team 3. The alternative hypothesis is that at least one mean is significantly different from another. Now we'll conduct a one-way ANOVA test here because the three teams are independent. To conduct ANOVA test, click Data, Data Analysis, scroll up here, select ANOVA single factor because we only have one response variable, which is number of fielding errors. Click OK. Now input the data, so you highlight including the labels. Check columns because our data is grouped by columns. In case the data were grouped by rows, then you would check rows. Now check labels because we included the labels as well, team 1, team 2, team 3. We leave our alpha value as 0.05. That will be our level of significance. Now I want to display my results here. That's why I select the cell G2. Click OK. The results of the ANOVA are here. Okay, let's begin with the summary statistics. Now count. There were 12 players in each team. This shows the total number of errors for each team. And then we also have the average number of errors in each team and the variance of errors in each team. Okay, we can see team 1 had the smallest mean. Sorry, team 3. Team 3 had the smallest mean number of errors, followed by team 1, and team 2 had the highest number of errors. Okay, let's move to ANOVA summary table. We have sum of squares values here, the degrees of freedom, the mean sum of squares, the F value, the P value, and the F critical value. Now, F critical value is just the value that we will compare against the F statistic. Now, if the F statistic is greater than the F critical value, then we reject the null hypothesis. Now, the F value is 8.107. The P value is 0.001. Now, this P value 0.001 is less than our significance level, which is 0.05. So we reject the null hypothesis. These results show that there exist significant differences between the means of the three teams. So because our results are significant, we need to follow up the ANOVA test with a post-hoc test to determine which pairs of teams had significant differences in their means. Now, there are a number of post-hoc tests. We have Bonferroni test, Turkish test, safest test. But in Excel, conducting Bonferroni test is the easiest. So we shall follow up the ANOVA results here with the Bonferroni test. Uh, we shall first of all do pairwise comparisons using independent t-tests. Then we do Bonferroni correction. Okay, so in our pairwise comparisons, we shall compare team 1 and team 2, then we compare team 1 and team 3, then we compare team 2 and team 3. We shall do 3 pairwise comparisons before we do Bonferroni correction. We need to do Bonferroni correction because uh, we shall conduct a number of pairwise comparisons, and we need to do Bonferroni correction so that we reduce chances of making type 1 error. Okay, let's begin with the t-tests. So click data analysis, scroll down to t-test to sample assuming equal variances. Click OK. Now a variable 1 range, put team 1 data, variable 2 range, team 2 data. Okay, check. Okay, the hypothesized mean difference is 0. Check labels. We leave our alpha value at 0.05. Output range, we want to display my results there. Click OK. Next, I will compare team 1 and team 3. Okay, let me now put team 3 here. Team 3 data. Okay, let me now display my results here. Next, I'll now compare team 2 and team 3. Okay, now let me display my results somewhere here. So we have the 3 pairwise comparisons here. So team 1 and team 2, these are t-test results for comparison of team 1 and team 2, then team 1 and team 3, then team 2 and team 3. 3 pairwise comparisons. Now we are interested here in the two-tailed p-value. Let me just mark it with a different color. Okay, now we shall do a Bonferroni correction here to reduce chances of making type 1 error. Okay, let me write Bonferroni adjustment. Now in Bonferroni adjustment, we shall divide our alpha value by the number of pairwise comparisons. So we put equals to our alpha value is 0.05 divided by the number of pairwise comparisons, which is 3. So we need to compare the corrected significance value to a two-tailed p-value for each comparison. Let me write this. I want to check whether it is significant, results are significant or not. Okay, so just write equals to, we want to check whether the two-tailed p-value is less than, so just write less than or equal to this value here. So we find it's true. So the two-tailed p-value is less than our new level of significance here. So it means that there exists a significant difference between number of errors committed in team 1 and those committed in team 2. So there's a significant difference between mean for team 1 and team 2. Now we shall do the same comparisons for team 1 and team 3 and team 2 and team 3. So just copy and paste here and paste here as well. So you can see comparing team 1 and team 3, there were no significant differences in their means. You can see the two-tailed p-value is greater than 0.01667. So there were no significant differences in errors committed by players in team 1 and team 3. And here there were significant differences between mean for team 2 and team 3. Yeah, that's the end of ANOVA test in Excel, followed by a post-hoc test because the results were significant.